Welcome to Jap
and Ruski.
channel.
We're here today to learn some physics.
Ha.
Hello everyone. We're here today to learn Newton's first laws. Yeah, we're starting with basics. So, Newton's first law states, a body will remain at rest or moving with constant velocity unless acted upon by an unbalanced force. So, how do we put this in understandable words? Well, you see, Shinny here drew an object moving on an ice rink. Why did you choose an ice rink, Shinny?
Well, ice rink doesn't have much friction. We could almost say that the friction is zero.
So when you push that object, it's just going to continue forever. With constant speed constant velocity, all the way till infinity. Why? Because the object has no resultant force acting upon it. And if it has no resultant force acting upon it, then what happens? What does that mean about acceleration?
The acceleration is zero. The object is not accelerating.
Yeah, that's why it has constant velocity. So if it started with zero velocity, it'll continue with zero. If it started at 20 kilometers per hour, that's how it's going to go. Now we're going to go to second law. Hello everyone. Last time we were looking at Newton's first law of motion. Well, this time, as a continuation, we'll be looking at Newton's second law of motion. Yes, you did guess it. That's right. You know how to count. Well, the second law of motion states, the acceleration of a body is proportional to the force applied and inversely proportional to its mass. Or F equals ma for those of you who like equations. Force F equals m mass times acceleration a. That's simple. Well, let's look at an example. For example, if an egg was falling down from sky. Not that eggs always fall down from skies, but you know that Meat Cloudy, I don't know, whatever movie they filmed. Maybe it was falling, maybe eggs will be raining one day. So Shinny, tell me what will be the acceleration due to gravity on that egg?
Well, specifically, the acceleration due to gravity would be 9.81, but in this case, we could just possibly use 10.
Exactly. We're gonna just round things up a bit. 10 meters per second. Meters per second squared, to be precise, is exactly the units of acceleration. And the mass of that egg is going to be, well, I don't know, 0.2 kilograms? Make sure not to say 200 grams, because grams is not actually an international physics term.
Trying to use kilograms all the time.
Shinny, could you please draw an arrow showing the direction of falling of the egg? Yeah, it's almost like a force diagram, which we will be looking at in later videos. Now, let's calculate the force that the egg has been applied to. Force equals m times a. Shinny, make the calculation.
Alright, since F equals ma, we have the acceleration, we also have the mass. That means that we can find the F. So 10 times 0.2, which is 2.
2 what? 2 newtons.
2
exactly,
newtons.
Newtons as in the unit of force, named after the guy Isaac Newton who came up with all these laws as you worked out from Newton's second law. The name kind of states it. Good job. This is Jap and Ruski Productions.
Thanks for watching, guys.
And come back next time, you hungry physicists.